Now we're going to look at a couple questions from part B. Now, in the first question here, what we have is we have two different sets, and we're asked to either prove that they're a subset directly or provide a counterexample. And in both cases, what I'm going to start with is, are they non-empty? And in both cases, the first one we can see, okay, 0, 0, 0, and the 0 vector is in W as 0 plus 0 equals 0. Therefore, W is non-empty. Okay. Now here, we look at this vector or this set of vectors. We can look at it and we can go, okay, X, Z has to be 1, 0, 0, 1 is in W as Z1 equals 1. Therefore, W is non-empty. Okay, so now we've got the non-empty portion. Now we're going to let V1, V2 be in W, and C be in R. And the reason why I'm letting C be in R is because I'm working on R3 and R, real vector space. So our constants are real numbers. And now we're going to then V1 equals X1, X2, X3, where, or X1, Y1, Z1, where X1 plus Y1 equals 0, and V2 equals X2, Y2, Z2, where X2 plus Y2 equals 0. Consider CV1 plus V2. And now CV1 plus V2 equals C X1, Y1, Z1 plus X2, Y2, Z2, which equals CX1, Y1, or CY1, CZ1, plus X2, Y2, Z2, which equals CX1 plus X2, CY1 plus Y2, CZ1 plus Z2. Taking the sum, let me write that a little nicer. Taking the sum, C X1 plus X2 plus CY1 plus Y2, this is equal to CX1 plus Y1 plus CY1 plus X2 plus Y2 by commutativity, which equals CX1 plus Y1, and this is commutativity of standard addition, plus X2 plus Y2, which equals C times 0 plus 0, which equals 0. Therefore, CV1 plus V2 is in W. Therefore, W is a subspace. But let's see what happens here. And we just need to provide a counterexample to show we're not in the subspace. So here we are a subspace. Here, turns out this isn't going to be a subspace. But what I would do is I'd still try. Just let V1, V2 be in W, C be in R. V1 equals X1, Y1, Z1, V2 equals X2, Y2, Z2. Consider CV1 plus V2. CV1 plus V2 equals C X1, Y1, Z1 plus X2, Y2, Z2, which equals CX1, CY1, CZ1 plus X2, Y2, Z2, which equals CX1 plus X2, CY1 plus Y2, CZ1 plus Z2. Now here, CZ1 plus Z2 has to equal 1. But Z1 equals Z2 equals 1. Thus, C must equal 0. Well, C must equal 0. But what if C doesn't equal 0? Well, now what we can do is we can just say, okay, let's take 0, 0, 1 times 1 plus 0, 0, 1. We know that vector was in a W. And when we add them, we get 0, 0, 1 plus 0, 0, 1, which equals 0, 0, 2, which is not in W. Oh, we had a vector in W. We took a linear combination of it. We're not in W. Therefore, W is not a subspace. And there's our counterexample. I went through the same sort of process, but then instead of having a conclusion, oh, yes, I'm in the subspace, we get to a point where we go, oh, nope, not in the subspace. And then there's a nice natural counterexample where we can just use the original vector, multiply by the C's not equal to 0, and awesome.